Hello guys, welcome to Code Extreme. Today we are going to do Leetcode 39, which is combination sum. It is a medium tag problem. So it is a problem based on recursion, and it will help us to understand recursion more and more easily. So let's read this question. Given an array of distinct integers candidates and a target integer target. So I have given two arrays, candidates and a target array. Okay, return a list of all unique combinations of candidates where the chosen number sum to target. Okay, so we have to find all the combinations from the candidates whose sum is equal to the target and store them in a 2D vector or 2D array and then return it. Okay. Next, the same number may be chosen from candidates an unlimited number of times. This is very important thing, that we can choose a number unlimited times from the candidates array. Okay. So two combinations are unique if the frequency of at least one of the chosen numbers is different. So this means that we have to return unique combinations, unique combination. Like if we have 1 2 3, then we will not return 3 2 1, that is same. So we have to return unique combinations only. Okay, next thing is written that the test cases are generated such that the number of unique combination that sum up to target is less than 150 combinations for the given input. Okay, this thing did not benefit us. So let's see the restrictions of this question. So these are the constraints in which we have given the length of candidates and the range of candidates I. Also we have given the that the all elements of candidates are distinct. This is very important for us, that the elements in the candidates array are all distinct. Okay, and the target is from 1 to 40 only. So let's understand how can we do this question. For that, let's get back to the pen and paper. Let's start. See, we have our example one, in which inputs are 2 3 6 7 and the target is 7. Okay, so the output combinations, these are the combinations, and also we can take one element multiple times, unlimited times actually. It is given in the question. So 2 plus 2 plus 3 is equal to 7 and 7 equal to 7. So these are the possible combinations from this array which can add up to the target. Okay, so this is example 1. This is example 2, in which candidates is 2 3 5 and the target is 8. Our output is 2 2 2 2, in which we have 4 2 and the target is 8 and sum is also 8. 2 3 3 is also 8 and 5 3 is also 8. Okay, we will not return this, as this is not unique. This will be not unique. If we had pushed back this in this output, then it will be not correct, as then it will be not unique. We have to only return a unique number of combinations, so this is not correct. Okay, and example 3 is very easy. Our candidates is 2, target is 1. So it is not possible for this, matlab, means no combinations are there which can add up to the target, so we will return a empty array. Okay, also we have to return a 2D array here. Return 2D array. Okay, so what is the institution? What is the intuition? Intuition is that intuition, we can return all combinations first. Yes, we can return all combinations. Then we will see how to make that unique. First we will return all possible combinations which can add up to the target. Then we will see how can we make that unique. How can we make that combinations unique. Okay, so let's understand with the recursion tree that how can we generate all possible combinations which can add up to the target. Okay, so let's see. So I have taken 2 3 5. Okay, this is our target 7, and this is an empty array in which we will push back our combinations. Okay, so let's start. So how can we do this thing? We can do this thing that by how many number of calls? There will be 3 number of calls in each case. then only we can generate all the possible combinations. So in this branch, I what can I do is pushing back 2 in our this vector. Our original vector will be same, but what will be the difference is that we have pushed back 2 in this. So this will add up 2 in this array. Then we will subtract 2 from 7, and remaining will be 5. Our target is only 5 left. 2, as we have added 2 here, so the left target is 5. Okay, I hope you understand this. Now in this case we will take 3, and our left, which what we will left is 4. Okay, I am not writing this array because this is very big and will take space. Okay, that's why in this case we will push back 5 in our array, and the remaining will be 7. Oh sorry, 7 minus 5 is 2. Okay, the remaining will be 2. Now here again we will make 3 calls. So we can do, means it is possible to make these calls, as we can take one element unlimited times. It is given in our question that we can take this unlimited times. Okay, so in this branch we will add 2 comma 2, which will be 4. Then our left target will be 5 minus 2, which we have added now. 5 minus 2 is 3, so left target is 3. In this case we will 2 comma 3, we will push back 3, and the left target is now 2. Okay, now I will add 5 here, 2 comma 5, and the left target will be 0. And you can see that this is a possible combination, as 5 plus 2 is 7, you know. Okay, now let's do this thing with this also. 3 comma 3 comma 3 comma 2 from this. Okay, so the left target is 4 minus 2, which is 2. So the second call will be 3 comma 3, and our left target will be 4 minus 3, which is 1. Okay, you can understand this very easily. I hope you are understanding this. Now next call, 5 okay sorry, uh, 3 comma 5. The left target is 7 minus 5, which is 2. Okay, and this, you can see that it is taking very space in the copy. So this 5 comma 2, oh sorry, 5 comma 2, and the left target is 0. Okay, it is 0. And here 5 comma 5 comma 3, which is minus 1. Can you see something here? Last branch, what is happening here? Let's see this. Try to understand what is happening in these branches. Then we will discuss this also. Last is our 5 comma 5, which is 10. Okay, but 10 and 2 minus 10 is 2 minus 10. What is 2 minus 10? 2 minus 10 is minus 8, which is not correct at all. So we can see here a thing very important. 0 is our base case in which we have to stop, as we have find a combination which is adding up to the 7, our target. Okay, so when we get our 0 in our target, we will decrement our target call by call. Okay, so if we get 0, then we will return. So this is our returning condition. Also, when we get a negative number, in our target, you can see this or this also. What we are getting negatives means that the sum in this combination is greater than the target. So it can't be possible that this is a combination, as it is 5 plus 5 10, and it is 7. So it is not possible at all to push back this. So it is not correct at all. So we will return here also. In this case we will push back and return. What we will do, we will push this combination in our 2D array, and then we will return. But in this case we will directly return. What we will do is direct return. Okay, and for all other cases we will uh, further move our branch like this, further calling until and unless we get a zero or a negative number. I hope you are understanding this recursion theory. It is very important. Okay, also you can see, no, you cannot see anything else. So can we build the solution now? Yes, maybe we can build the solution now. So if you had understand the intuition, so let's try to do that with your own. Okay, but now we will do it with our also. So if you have understood the intuition properly, then try to do the code yourself. Okay, now we will see the code. So let's do this question. Okay, first I will make a 2D vector int. Okay, and name is answer, in which in which we will push our combinations. Now I will make a vector temp, oh sorry, int, whose name will be temp. Okay, now I will make a function whose name will be combination. I will pass here candidates vector, comma answer vector, yeah, or temp vector, target vector, and answer vector. All these I will pass all these, and at last whenever work will be complete after this call, then we will return simply our answer vector. Okay, now let's make the function which is the real thing. So we will make a void function combination we will take this vector and candidates. We will make this pass by value, as we will not change anything in this vector. That's why now we will make a temp vector. Now we will make our target, and at last vector answer, vector, oh sorry, it is right, int answer. Okay, now this is complete. So let's start. So what was our first base case? What was our first base case? That if our target is 0, if our target is 0, if our target was 0, then what we were doing is first push back the temp vector. Push back the temp vector. Temp vector is a vector in which we have pushed up our combinations. Okay, that was our temp vector, and answer vector was our 2D vector, in which we were pushing back our all temps or all combinations in the answer vector. Okay, so uh, answer dot pushback, we are pushing back a combination in which in temp. Okay, and at last we are returning. What was our second condition? Second condition is our that if our temp is less than 0, then what we were doing, we were simply ending, so return. As it is not possible for the combination to achieve the sum equal to the target, that is why we return here. Now the calls, the real thing. So how many calls we were proceeding with? We were proceeding with the calls equal to the size of the candidates vector. Let's understand this from here. The size of this candidates vector is 4. So here we will make 4 calls. Okay. In this case we will make 3 calls, and in this case we will make only one call. Okay, in this case we will make 4 calls, in which temp will get 2 one time, 3 one time, 6 one time, and 7 one time, and then it will further proceed. Okay, so how can we do this? We can easily do this by a for loop. So for loop, for int I equal to 0, I should be less than candidates dot size. Okay, I hope you understand this. Okay, now what we were doing, we were pushing back this too. You remember, we were pushing back, we were making in this case, like we will make 4 calls. in each call we will push back our element. For example, we were pushing back 2, 3, after that 6, and after that 7. Okay, so we first have to push back our element in the temp vector. So temp dot push back, push back candidates I. Okay, now what we will do is we will again make a call for you remember when we were pushing back this element, then we were making 4 more calls. For this example, 4 calls, but the calls equal to this equal to the size of this array. We were making more calls, so we will again call our function candidates. Candidates, not candidates, combination candidates comma temp comma target comma answer. Okay, and what we will do next, this is kind of backtrack. We will pop back our answer. We will pop back from our temp. So why are we popping back? When we were returning to the top of the tree, remember the tree diagram, when we are returning to the top, then we have to pop back the element which we had push back in the candidates vector. So we have to pop that also. Okay, so this is the thing. Now what we will do is run simple run, but this will be wrong as we are not returning the unique combinations, we are returning all of the combinations. Oh, memory limit exceeded. Why this is happening? Oh, we forget one thing. What is the thing is we are not subtracting our target, so we have to subtract also candidates I. You have to subtract from here also the candidates. Okay, we the element which we have push back in our temp factor, so we should also subtract it from our target. Okay, and this is where we done it. So now running this program, so we will get all the combination including the unique ones also. So this is empty. Why this is empty? This is also empty, and this is also empty. So what is the mistake we have done? Okay, I have found the mistake. The mistake is that we are returning this we are calling this vector by pass by value. So whenever we call our function, a new vector, a new 2D vector is uh, coming into the existence. Okay, so this is not correct. We have to make changes in one vector only, and that is this vector. This is answer. So we should pass it by reference. Okay, now we will run this function, and we will possibly getting the all the combinations. See, these are all the combinations. The sum of these combinations is 7. You can see 2 plus 2 plus 3 is 7, 2 plus 2 plus 3 is 7, 2 plus 2 plus 3 is 7, and 7 is 7. But you can see these are same. These are combinations, but these are same. So we have to return only unique. Okay, and in this case also, this is correct and this is correct, but these are all same. These two are same and these two are same, so it is not valid at all. And in this case it is very easy. So you understand, we have to return unique combinations. So how can we make this unique? How can we make this unique? So here only I will explain you something. So see here, what can you see is the valid combination 2 2 3, and the invalid combinations are 2 3 2 and 3 2 2. So the valid combination is sorted. You can see here it is sorted. It is in the form of, it is in sorted form, and these are all in unsorted or rearrangement. Okay, these are in rearrangement form. So the valid combination, these are all combinations. These are or you can say that these three are permutations of each other. So we will return or push the only permutation which is sorted, and we will neglect the other combinations. You understand? Let's see here. These three permutations are same. So we will return only the permutation which is in the sorted form. Also here there are two permutations of 3 and 5. So we will return or push back that combination which is in the sorted form. Okay, so this is the idea of returning the unique elements only. So how can we do this? So it is very simple. We will, when we are getting our target equal to 0, and we will not directly push back, we will check. How can we check? For int I equal to 0, I should be less than I should be less than temp dot size and I plus plus. Next what we will do is check if temp I minus 1 is greater than temp I. If this is happening somewhere in the temp factor, then we will return, we will end this function and this call, we will not push back. You understand? And if it was in the sorted order, then it will push back that. Okay, so for that I have to initialize this from 1. Okay, you understand this what I have done? So this will print only the oh sorry, this will push back only the sorted combinations. One thing more, that if my combination, for example here the target is 7, so my one combination will be 7. Okay, my one combination will be 7, so target will be 0 in this case. So I am initializing this for loop from I equal to 1, and it will not find any temp I, because temp 1, it is temp 1 is not here. Temp 1 is not in the existence in this vector. So we will make a condition here. If temp dot size is greater than 1, then only we will do this. And you can understand that 1 minute, I will close this. You can understand that if we will get one size temp, if its target is equal to 0 and this is the and the size of the temp is 1, then we will directly push back it. Okay, so we will write this here as if temp dot size is 1, oh sorry, 1 yes 1, then we will simply push back. So what we will be doing is push back the temp if its size is 1, simply. So, because we will not see any sorted idea in this, because it has no permutations, it is simply 1, it is unique. Okay, and here we will return, okay. So let's run this. I hope this will be accepted. So it is accepted. Okay, let's submit this. So if you understood this question, so don't forget to subscribe our channel. So see here, we have done this question. Okay, so don't forget to like and subscribe. Thanks for watching.